experience, some prior experience in knowing what the outcome of an experiment might be. So use the egalitarian probability function whenever you don't know anything about the experiment, right? You don't have any experience that would tell you that one outcome is more likely than the other outcome. Okay? So if you don't have any information about the experiment at all, you just, by default, go with this egalitarian probability function. But if you had some kind of knowledge about the experiment, then you would just use that experience to define your probability function. So think about it like this. So let's say that you perform some surgery like 1,000 times, right? So the first time you perform the surgery, if someone asked you what the probability of success of the surgery would be, you would probably tell them it's 50-50. Because I've never even done the surgery before, right? But if you've done the surgery 1,000 times, and let's say 900 times it was successful, right? So let's say out of 1,000 times, be successful. 900 times. Okay. So if you did this, then you would say the probability of success is 900 over 1,000, which is 0.9. So it's like 90% successful. But if you've never performed the surgery before, then you have no experience in determining which outcome is more likely. Does that make sense? So, like if someone flips a coin and they ask you what the probability of heads is, what would you say? It's 50-50, right? So it's 1/2. So if you flip a coin, and so what's the probability? So this sample space would be heads and tails. All right, if someone asked you what the probability of getting heads was, this is 1/2, and the probability of getting tails is 1/2. Okay? Because what you're doing here is you're using the egalitarian probability function because you don't know. I mean, you've never flipped this particular coin before. Okay? You don't know how much more likely it is to land heads than tails. So what you're doing is you're counting up all the objects in omega. There's 2, and then for each of these events, you count up the number of elements in this event. So there's only one event. So there's only one outcome in this event. This is just H. So there's one object in this event, and so the probability of this would be 1 over the cardinality sample space. This is 1 over 2. If I flipped a coin that had 3 sides, right? So if I flipped a coin, and like we're in some weird dimension where this coin had 3 sides, so it had like H, T, and Z, then the probability that it would be H would be 1 over 3, and the probability that it would be T would be 1 over 3. Does that make sense? So here, when you flip this coin, you don't have any prior experience flipping the coin. But if you flip a coin like 1,000 times and it landed heads 900 times, then you would change your probability function for this coin. Because this egalitarian probability function no longer accurately describes your situation. Okay? Because if you flip this coin 900 times and it lands, or if you flip it 1,000 times and it lands heads 900 times, then the coin is more likely to land heads. Do you guys realize that? So you would change, you would say, look, this egalitarian probability function is not a good model for my coin. Because it's not equally likely for this coin to land heads or tails. Because I've done this experiment 1,000 times, and it's landing heads a lot more often. Okay? So then you would say the probability of it landing heads would be like 900 over 1,000. and the probability of being tails would be 100 over 1,000, right? So you change your probability function to fit your experience, okay? But if you don't have any experience at all, then you would just go with this egalitarian probability function by default. So like in that die rolling example, someone asks you for the probability, so if you roll a die and they ask you what's the probability of 1 to 5, then what would you say? 1 over 6. So then you're just automatically assuming that you'd be using this egalitarian probability function. So this thing. Do you guys have any questions on that? So let me so anytime you hear somebody say something like the probability of getting struck by lightning is such and such, right? Like so where do they get that probability? Right? So what they're doing is they're somehow looking at like the number of people that walk around like at a certain time of day, and then they count up how many people get struck by lightning, right? So it wouldn't be 50-50, right? So you're not always going to use this egalitarian probability function, right? Like when you flip a coin, you use this egalitarian probability function. When you roll a die, you use this egalitarian probability function. But if somebody asks you like what the chances of getting struck by lightning are, you wouldn't tell them, it wouldn't even make sense to use the egalitarian probability function, right? So you'd have to define a probability function based on your experience of how many people are getting struck by lightning. Does that make sense? So you can define the probability function based on the experience you have performing your experiments. Okay? That's the whole point. So let's see, like this. Let me tell you about odds. So odds. So also I should warn you that probabilities don't tell you what's going to happen. Right? They just tell you how likely something is to happen. And where you get these senses of how likely things are to happen is from experience. Okay? So if you flip a coin and you say the probability of it landing heads is 1/2, then you're telling me how likely you think it is to land heads, and you're basing it off of your experience flipping this coin. And in this example, you have no experience flipping the coin, so you just automatically say everything's equally likely because I don't know anything about what's going to happen. But if you had performed a surgery like 1,000 times, right, and someone asked you how likely it is to be successful, then you would get your sense of how likely it is to be successful based on your experience of performing the surgery. So if you performed it 1,000 times and was successful 900 times, then you could say it's going to be 90% successful. So the probability is 0.9. And you base that off of your experience. So let me tell you about odds. So if So odds, when you usually calculate, you go from probabilities to odds and odds to probabilities. So if, let's say you have an event E, and it has probability P of E. So then the odds, so I'm defining what this means. So the odds for E are this, so it's P of E, so the probability of E divided by 1 minus P of E. So if you have an event E and it has some probability P of E, then you define the odds for E to be P of E divided by 1 minus P of E. And the odds against E are the reciprocal of this, so it would be 1 minus P of E over P of E. so that's going from, you know the probability, and you turn that into odds. So now if you know odds, so if the odds for E, I guess, for E are A to B. The odds are A over B, so A to B. And then this probability of E, it'll be A over A plus B. If the odds against B are A over B, then the probability of E will be B over A plus B. And I guess you should note that if the odds for an event are A over B, and then the odds against it against it are B over A. Let me give you an example. So let's say it's the probability of rain is 3/5. Then what are the odds against rain? So I want to find the odds against rain. So they tell you the probability of rain. You want to find the odds against rain. So 1 minus probability E over probability E. And this one. This probability of E would be 3/5. 1 minus 3/5, 3/5, 5/5 minus this. This is 2/5 divided by 3/5. So you have 2/5 divided by 3/5. So how do you do that? So how can you simplify this? Do you guys know how to simplify a fraction divided by a fraction?
Multiply by a reciprocal.
Yeah, so you take this bottom one, you flip it, so it's reciprocal. So you take this bottom one, you flip it over and multiply by that. So this will be, so you leave this top one here. So you take the bottom one, and you take the reciprocal of the bottom one. So you flip this over, and you